test the song, press P, enter.
Okay, so it's a test song. Okay, so you send a P to it, and it's playing the test song. So if you see all the songs are stored over here, right? Totally, you have 4 songs. A test song, which is the one I just played, which is a little bit longer, and then a copy song, which is for task 2.3, which is the last task. The copy song plays several notes or 6 notes and ask you to one more here and ask you to duplicate the rhythm of it, right, with the push button. So you have 4 songs definitely being stored in here. The task song, which is just directly being played automatically, and a copy song, we'll talk about that for the 2.2 task 2.3, and then a full song, a success song, and a fail song. So these are the other 2. So you totally have 4 songs, right? So for this one, whenever you press it, it starts playing. And so this is what we did on Monday. Okay, so during the Monday lecture, my laptop crashed, but I was using that one, so it was not recorded. So the thing is, if you look at the code that you need to fill in, you can see here. So this one is timer 1 is to play the note. Okay, so if this is true, it's gonna play the note. That's a play note ISR. No matter where that is, if you enable timer 1's interrupt, it will interrupt and get into that ISR for that timer 1's setup, the timing, and play the note. It won't play the whole song, but it will play the note, depending on where the index is at for that moment, right? So the question is, for number 5, you don't really need the play song flag to be on in order to play the note. If you want to play the song, yes, you need to turn on that flag. Otherwise, you just need to turn on the play note flag, and it will be able to play the note. But someone has a question here, like, hey, for task 2.2, which is the one I just showed you during the demo video, right? It plays the song first. You turn on the play song tag first here, right? And then it starts transitioning among all these different states. So you get into idle first, and idle then move to the next, play the note. So if you are playing a song, of course you need to turn on both flags. So you enter the idle, you turn on the play song flag, and then it moves to the next state, we'll turn on the play note flag as well. So both are on in order to play a song, because you are playing the song and the note at the same time. All right, so this one is the timer 1, timer 3 interrupts, ISRs combined will play the song for you. One, the timer 3 is for the duration and the rest, and timer 1 is for the notes. Any questions on this before we moving forward to the next problem? Any questions?
The answer is yes.
I don't know the answer. I just explained to you already. I cannot directly tell you the answer. I almost told you already. So what's the question here? Number 5. You have to set that flag true in order to play a note at any time. What's that?
No.
I can't tell you. I already explained to you already. All right. So another thing I want to explain and show you guys, because this is already overdue, already submitted, so I think it's fine to show you the answer here. So you want to open your in class number 6. So the answers will be there. It's pretty fundamental, but I'm just repeating myself. I'm just repeating. I think a lot of times we need to keep repeating as an instructor, repeating. So in order to let you guys master the materials, okay? I'm sorry if I'm boring you, but I think most of you really need to get something repeated, okay? So this is the answer, the solution. I believe people have reached the correct results in different ways. And congratulations if you have already get it done in the correct way. But if not, here's how I did it. So what we did for that task, remember? It was also playing a song automatically. Let's go back to this one real quick. So push a button to play a song, right? So push it once, and then it automatically plays the rest of the notes. So in that case, to detect that push activity, you need this part. Where's that? No, not that one. Sorry, not that one. This one. So this is not anything that you should use ISR, because by that moment we haven't learned ISR yet. So it's gonna be a nested while loop. You need to know how to use the nested while loop to get this implemented. So first, to detect the push activity, right? The push or event. This one will hold it there when it's high. So whenever it gets into the loop function, it will stay here forever if you don't push it. Because that's the semicolon will end it, right? There's no curly bracket to include any activities in there. So it's basically while it is high, because that's the zero active zero button, right? So if you don't push it, it's being put up to BDD, it's gonna hold there. You push it, it moves to the next. You push it, moves to the next. And then you release it, it becomes high again. You can see here there's no semicolon anymore, and directly get into this curly bracket, has all these lines to be executed. So these ones, even though rote memorization is a lot of times is not recommended in the class, but for these fundamental ones, I still require you guys to memorize it. In the future, it will be in the exam. Just let you guys know, okay? And no, it's going to be closed notes, closed book. There's no book, but closed notes, right? And so I will potentially ask you all the questions I put on in class number 6. So you want to keep this paper and make sure you can answer all the questions without looking at the notes. All right, how to set up timer 1's prescaler to 1 to 256. So 256 is a CS what? CS1 what? 1, 2, right? This is over here. Okay, and all the prescalers available are 1, 8, 64, and 256, and 1024. So these are all the ones available. And it's basically counting from 0. The first one is 1, right? 1, 2, 3, 4, 5. Okay, so basically you have 5 different prescalers if you're not including the first one, the 0 one, which is turning off the timer. So there are 5 different prescalers. It's counting from number 1 to number 5. So in the exam, if it's closed notes, I'm asking you to set it up to like 1 to 64, right? Can I do that? 1 to 64. So you have 5 prescalers. So 64 will be the third one, right? The third one will be 1, 1, right? How to set up 1, 1? So it's basically setting up 2, right? 2 ones at the same time. Remember, we can do it with a one-liner. One-liner. How? If it's timer 1, I'm talking about 64, not the one over here, right? If we do it 64, it's timer 1, right? And do it one more time. Okay, if you have 2 bits to be set, then just do this. If it's just 1 bit, just do one of them, right? This is for 64, 1 to 64. And everyone should know this really well, right? Super basic. Let's come back to the code. Questions on this? Nope, right? So for setting a bit, you do OR, right? OR, and then do this. Okay, don't want to spend too much time on this. Now come back to the code. So timer 1 is for the duration. You see, timer 1 is for duration. And timer 3 is for the note. So in that case, you want to set up timer 1 first. So while timer 1 is still counting, you toggle your notes. All right, does that make sense? Because the notes, you toggle the notes, the speaker pin for the note, for single note, it requires a higher frequency. So you have a duration as a outer layer while loop, and then you get into that while loop. While it's still during that duration, you play the note. Make sense? That's how we do it. So a few things are very important, and I think it's sort of like a feedback from students board when I troubleshoot with you guys. So if you hear a really low volume from the speaker, it's probably you didn't turn it off over here at the very beginning. So this is super critical, even though sometimes it's getting ignored. But you need to turn off, set up as a normal mode first, and then turn it off. Stop the timer in the setup function. Super important. You have to do this. All right, and then you get into it. It starts whenever the press event is detected. It gets into here. So what are the steps to deal with the timer with the pressing event? So these ones are all the fundamental steps, and you guys need to memorize, and it can show up on the exam. So what are these? Turn on the timer. Which one turns on the timer? When you assign prescaler to it, it turns on the timer. Keep in mind, this will be on the exam. Whenever you set up a prescaler, it turns on the timer. You turn on the timer, you give a count to the counting register. You know, what's the name of the counting register? It's a timer CNT 1, 2, 3. It doesn't matter which one, okay? It's a TCNT something. Okay, and then you minus that number of counts from the 2 to the 16th if it's a 16-bit timer and counter. There might be a trap on the exam. If it's an 8-bit, you want to use what? Which timers are 8 bits? 0 and 2. And the rest are 16 bits. Okay? 1, 3, 4, 5 are 16 bits. 0 and 2 are 8 bits. So 1, definitely, timer 1, I just told you, it's a 16-bit timer. So I'm using 0x, which is the hex number, 1 and followed by 6 zeros. It's basically 2 to the 16th, right? So it's the total count, total number of amount of counts. And then use that one to minus the desired counts to set up the starting value. So the timer will start from there, all right? So you start a timer, set up the starting value, it will be ready. What's the next step? It's pretty simple, right? I want to start a timer. I start a timer, give a starting desired starting value, and then I'm just waiting there, right? Just waiting to let the timer rolling. So that's how you wait. So while it's timing, it's counting, right? So you are detecting that this overflow bit, the overflow bit is not turned on, which means still counting. And this one will be the condition you are checking. So how you are checking that overflow flag. The TOV1 bit is the LSB of the TIFIR1, which is timer interrupt flag register 1, right? So that registers LSB. That registers LSB, which is the TOV1, will be turned on when the timer's up. Okay? So whenever it's not up, that LSB will be 0 all the time. So that's something you can use as a condition to do the rest. When the timer comes to counting, you use that condition for the while loop. And this is how you check it. This is how you check it. It's doing an AND logic. So remember this little one, how many bits are in here? This little one, how many bits? For the single one, how many bits are in there? 8. So that little one being shifted to the left by how many bits? Here, how many bits being shifted to the, so that single one, right, A bit 1 is being shifted to the left by how many bits? 0, because TOV1 is LSB is a bit 0. It's being used as a number here. You can consider TOV1 is 0, right? So it's basically A bit 1 being shifted to the left by 0 bits. It's not changing. It's not shifting at all. So that A bit 1 being ANDed to this register. So it's basically ANDing that 1 to a bitwise AND to the TOV bit of this register. If it's a 0, 1 and 0 will be 0, right? So if it's not being turned on yet, which means it's still counting, so TOV1 is still 0, then you are getting this condition being satisfied. It's still counting. It's recorded. So hopefully this is not crashing today. This is recorded. Come back to this one if you don't understand it. Okay? And then it gets into the while loop. What you want to do? When it's still counting for the duration, what you want to do? Play the note. How to play the note? Use timer 3 to play the note. So now I want to turn on timer 3. Does that make sense? I need to turn it on. How to turn it on? Here, give a prescaler to turn it on. And no prescaler or one-to-one prescaler because playing a note requires a higher frequency, so I don't want to slow it down. It works. Okay? And then I turn it on, and then I give, remember all the steps? It's always just repeating, right? So turn it on, give a count. That's it. You turn it on, give a count, it starts counting. That's it. So the next, for timer 3, you give a value to it. So this is how you reference the single notes in the song. And then you start a timer, you give a count, then you wait there. Okay, you wait there. So my question for you guys is, when timer 3 is counting, does interrupt work or not? Timer 3 interrupt. Does it work? So when that line, the while something, that line is being executed, it's waiting there, right? While timer 3 is still counting. Does ISR work? Okay. Of course, it still works. You didn't disable it, so it's enabled. So ISR always works. But how that works? It interrupts where? Interrupts for that while loop, right? So the while loop is still just going back and forth, just staying there, right? And interrupts, do the ISR, and come back. It's still waiting since it's not getting satisfied yet, and then go to ISR and then come back. That's how you hear that note. It's doing that for half period all the time, and come back to the well, check. Oh, it's still, the flag's still not on, and then go to ISR and then come back. Keep doing that. So that's when you are hearing that note being played. All right, and then once the TOV3 is getting the flag of this flag is on, which means timer 3 is up, it gets out from this while loop and start doing this. So what you want to really do over there? When timer is up. Oh, sorry, actually timer 3. Yeah, it's all going there, but so whenever this timer is up, it goes to here. Turn off timer 3, and then reset this bit to re-enable that timer 3 interrupt, and then flip that pin to play the note. So what I said probably was a little bit wrong just now. So actually when it's waiting there, it's just still during that half period. It's not flipping yet. It's not really playing the note. It's just holding at that voltage level. You know what I mean? It gets out from this while loop and then flip it. Toggle it over here to play the note. Any questions? Anything? All right. So during the duration here, right, for this curly, within that curly bracket, it plays the notes for that certain period of time. And when that is done, you turn off timer 1, which is for the duration, and then you reset your timer overflow flag because it was on because of the timer is off for timer 1, and then you break it for this amount of microseconds to play the rest, which is a break between notes, and then you increment your index for the note so you can play the next note next time. That's it. So this one, just use a nested while loop to play it, but I can tell that to control that, it could become super complicated if you have like more stuff in there to be covered. So it's better to use ISRs in the future. That's why after this tutorial, we started handling the same thing. You can see the results are the same, but it's being handled in a way nicer way using ISRs instead of using nested while loops. Could imagine you have like 100 nested while loops in the future. Okay, so for final projects, there are many things you can do, but I highly recommend that you guys think about a little design that can solve your everyday life problems. Like a lot of times you're thinking about, hey, this one problem can be solved by this little design or invention, and you can design the system and potentially sell it to others, because if you have that problem, maybe other people have the similar problem as well. Okay, I can give you one example, and I recommend you guys to, some of you, if you're interested, you can start working on it. It's super practical, which is called a burner alert. That came from my life, because my wife, after cooking, sometimes she forgot to turn the burner off, and especially for you guys have roommates, and he's laughing because probably you have, a lot of people have roommates, they forgot to turn it off and trigger that smoke or fire alert alarm in the house. It could be really dangerous, right? And I have thought about many ways of doing that, because I've seen this a lot many years ago. But after I installed that burner alert, I've never seen that happen anymore. That was probably 4 years ago. So I think about many different ways to do it. So for example, I can install an IR camera on the top of the burner, and so detects the temperature based on the places which is still getting hot, and then I can use that IR map and project it to a monitor in the house. So it's a big monitor hanging on the wall. So before you leave the house, you can see, oh, that's still burning. It's still like red. But the thing is, after turning it off, it will keep warm for a long time, and you have to wait, right? Before you leave the house, to wait there it doesn't make sense. You can just go there and turn it off, right? Just check it. So that doesn't really work. And temperature sensors, a lot of people will think about that. Probably the first thing came to their mind. It can detect the temperature, but the thing is, it's still getting hot, right? You can, do a little math for the microcontroller. Just get a temperature changing, right? Get a derivative over time and see if the temperature is changing or decreasing rapidly, so you know it's turning off. But still, you still need to wait. There's still a delta T over there, right? And I have thought of so many different ways. And if you search on Amazon, there are different products for this purpose. But there's a single one I found out was super simple and very effective. That's why I haven't seen this occurred in the past 4 years. It's called a burner alert, and I think it's like $40-something. You can buy 4 of them, And if you search for the companies, I think it's in, I forgot where that is, Minnesota or somewhere. Only 2 or 3 people in the company, and they have a $500,000 every year for the revenue just collecting from this single product. So you can imagine if you just invent something like this and keep selling it, and it's way better than getting a regular job somewhere else, right? It's giving you the 2 people on the team $500,000 a year. What that works is it's a plate with a PCB inside, and you attach it to the knob, and whenever it's getting tilted or getting turned on, it's detecting the angle and it will beep a little bit. So at the very beginning, it sometimes can be annoying because think about that. If you are cooking, it keeps beeping. It's very annoying, but actually it's not. So how that works is you turn it on for a little bit, it beeps 3 times, and then when time elapses, it's not always beeping. So it's longer the time, the less frequent it's going to beep. So the first you turn it on, it beeps 3 times, and then it takes 2 minutes then it will beep again, and then maybe the next time it will be 10 minutes after that, it beeps again. So what's the chance that you are missing that beep and leave the house and leave the burner on, right, all the time? So the chances in the past 4 years have never had this, single occurrence at all for the past 4 years. This is super effective. Otherwise, before the 4 years ago, I think I had this probably happened once or twice a month. Now it's been 4 years. So in that case, you can imagine there will be a little accelerometer in there or gyroscope. You can detect the angle. And how to manage the timer and ISR to give you the beep at different times after you turn it on will be something you can think of, right? And it beeps twice when you turn it on, and then beep 3 times afterwards, and it's a planning. So I can purchase that for you guys to look at it, and we just duplicate whatever, but make it cheaper, right? So they sell it for $80. I think we can make it maybe within $5, include the PCB and everything. So this is one of the examples you can use for your everyday life. There are many other examples you can use. Some people want to, design a little sensor for the 3D printer to monitor the temperature of the hot plate, or anything you can think of to be used in the house. Okay. All right. Before we move on with the next task, any questions for this one? This will show up on the exam for sure because it's just super fundamental, and for all these operations, right? Did I answer the question on paper? The first one, yes. Second one, the SQL load the number to timer 1, yes. Do you know how to count the timing? So here, I'm doing a 0.5 seconds for the duration, so I'm playing that single note for half second. Okay, how that works? How fast is counting? 16 mega counts per second, right? Divided by what? 256. That's how fast it's counting, right? So you can see here's second at the bottom. And then if you need a 0.5 seconds, you need a multiplication actually, because this can cancel that. So you can get the counts, number of counts, right? If I have a different amount of time, you just replace this number with a different one, whatever on the paper, and then find out the counts you want to use or to be loaded in there. So question number 2, make sure that you're using the 256 as a prescaler instead of 1. Number 3, check if the LS, what's that?
Oh, why is there the 5 in the bottom on the?
Oh, that's seconds, not 5. Second.
Oh,
I'm sorry.
okay.
Counts per second. Any other questions? Number 3, check if the LSB of that register is 0. So it's just an if statement. If that one and that, whatever the shifting, I have everything in the code here, right? I have it in the code. So do an AND logic and see if that's 0. That's in the if statement. So stop timer 3. Stop it. Just give the TCCR1B register a 0, right? It's going to be a 16-bit hex number 0. Stop it. So these are super fundamental operations. Stop the timer, start a timer, set up prescalers, check the overflow. Let's see. Are you able to follow at all? Are you able to follow? Most of them, at least. So you guys are turning in this and the last one by the end of this class. Okay, I'm gonna grade it this time. Write a 1 to it. How do I write a 1 to it? Right? The or equal sign, whatever 1 shifted to the left by that bit. Right? Write a 1 to it. Disable it. Disable the interrupt. Disable the interrupt. So the interrupt is TOIE, right? So I have the example code here. I think this one, yeah. Enable it. Enable timer interrupt is this. And disable it, I covered it last time. So I think you can refer to the in class number 5. I think you must have something written on that one. So that's enabling that timer interrupt. You want to disable it. It's going to be an AND logic here, and you want to invert it in front of it, right? Instead of having a O zeros and a single 1, you need a O ones and single 0, so you can disable it. Make sense? The puppy need a quiz. Puppy will become a computer engineer after this class. Enable it, enable that interrupt. Disable it, enable it, right? It's 2 different operators. So this is enabling it, disable it, you need an AND logic, and you need an inverse of this whole thing here, right? Stay here if the button is held down. So keep in mind it's 0 active. If you look at the schematic here, right? So it's a pull-up resistor. So if you don't push it, it's being put up. So it's gonna be a 1, right? So if you don't push it, it's a high. Push it is a high. So in that case, if you push it, it becomes 0, right? So stay here. Stay here is a while loop. Just stay there. If the button is being held down, which means you need a digital rate of the button, right? Where's digital rate? But you know how to do it, right? Digital rate here. No, it's a digital write. You digital read that button and that button pin, which is here, the button pin, pin 9, digital rate it. And if that one is 0, which means it's being held down, you'll stay there, okay? All right, that's all the questions on the paper. Any questions? Any questions? More confident this time. Now let's we have to do it quick because I will make sure you guys are ready for that one due on Sunday. So let's get in there. Get in there. The music box game. I already showed you, so we spent time on Monday and today regarding task 2.2. I think you guys should be ready for that. And for task 2.3, I lost in connections. There's no internet. Task 2.3 is here. 2.3. There's a template of that one. Template. Okay. First, again, let's play the demo really quick first, and so you know what we are going to do, what we're expecting. What are we expecting?
To play the music game, first, to play the copy song, press R and press enter to send it. So listen.
Basically, you press R, a lowercase r, it will directly play that copy song, only 3 notes. Okay, you'll play it. So you hear that, and hopefully that will seal in your mind, and then you duplicate the rhythm by pressing the push buttons, right? And then right after that, you start pressing. So there's nothing more to be sent by the serial monitor in between. So how that works? You play it, right? You send R, you play it, and then it's waiting for the customer to press the button. So what technique we have learned to let it wait for the customer to press? While something, right? So you you send R to it, it plays a copy song, okay? And then the microcontroller is gonna wait there for the customer, for the user to press the button. Okay, it's waiting for someone to press the button. So what's the line? What's the one line to do it?
Visual read button pin is high.
So while it is high, right? While it is high, and followed by a semicolon. So it's holding there, right? Holding there. Nothing in the curly bracket. Holding there. So you press it, it do something else. Okay?
To the pattern and try to duplicate it by pressing the bottom button.
So that's a success. So you press it. When you press it, it plays that note. You press it, plays that note. If you don't press it, it doesn't play the note. Okay? And then after you are done, right? After you are done, it directly plays that success song. Okay? It seems pretty complicated, but I have like 90% of the code is provided in the template. So now let's go through this really quick. First, just let you guys know, okay? And the state machine, the state diagram covered on Monday. Works for this one, so you are not changing anything here. If you finish task 2.2 and the state machine works for you for 2.2, you don't need to modify it. It's nothing but just interrupts playing the song and playing the notes. It's a modular design. You just directly use it. However, all the different operations and handling the signals is being handled in here in the case R. Just let you guys know. Okay, don't change it. Seem like you have another big chunk of code being taken away, and so it's the same thing. If you finish 2.2 and it works, it will work here as well. Don't change it. All right. So this part is easy. The ISR part is easy. Don't change it if it works. And I already told you what are these during the class. I wrote it here, and make sure you have all these conditions being put in the different states, and it should work. All right. And don't wait until Saturday to work on it. Start right away, because you need a task 2.2's results for task 2.3. If you're not getting credits for that one, then you are missing all the information for task 2.3. So now let's come back here. See where is the first one for your code. So on the top, so provided, and moving to setup. Okay. So this is not 1-to-1. I told you guys there's a typo here. It should be 1 to 256 because one is for note, one is for the duration. And enable the two interrupts right away, and enable it. Then it gets into the loop. It gets into the loop. All right. So see here, that's the first one you need to fill in. Is there nothing about the the design. It's just a simple question. You can find from the paper in class number 6. Clear that TUI E3 bit to disable that timer interrupt. Oh, I just need a timer TIM mask 3, and I do an analogic and inverse of that one shifted to the left by this bit, so I can disable it. Why I want to disable it? You press R. So before you do anything else, you just want to disable it for now. Okay, just disable it so it's not keep playing anything. And then it's asking, because it was quiet. After you turn it on and upload the code, it's not actually playing anything until you send the command to it, which is R. Right? So that's why it's telling the user that use the bottom button to reproduce this pattern. Oh, I was wrong. Sorry. So after you send R, it actually plays the copy song because the playing song flag was turned on immediately, right? And then you have a semicolon here to wait until it becomes false. So which means you press R, it send the R through the UART, through the serial, and it will start playing the copy song immediately. This is what we observed from these demo video, right? And the thing is, well, that song is finished. See here? Whenever it's done, I think I covered that on Monday. So for this state, you need to check the condition. If it plays all the notes, you want to set the play song to be false because the whole song is only played once. So whenever the song is finished, it will turn off that play song flag. So it's not playing the song one more time. So in that case, after that is being played, the song is being finished, the playing song flag will be false, right? So in that case, it jumps out from that while loop and start doing this. So you want to disable it immediately because after it plays the song, it becomes quiet. It's not playing that another time. Am I missing anybody? No? This one is easy, right? No matter if you understand this one, but this is easy. And then keep going. It stays here, right? It stays here, like what we just I just said, right? It stays at high because it's waiting for the user to press it. So before the user press it, it was high. It's being put up. So it's waiting there, right? It's waiting there. And you press it, it jumps out. It jumps out. And do this first. And this is waiting, it's doing this while loop. So at the very beginning, I took these out from the code, but I felt that it's probably too much for you guys to get it done by Sunday. So I just added all these things back. So you don't need to modify any of these ones. These are just checking the duration for between the price events. So it's having a delta here, plus minus little tolerance, because no one can perfectly match the rhythm and the duration of the copy song. So it's giving you a little tolerance here, like plus minus delta. As long as it's within that range, it's actually claiming that's a success. Okay? If it's out of the range, it's claiming a false. So it's giving a false to success. It's not success. So we don't have to mess with that part, which is good. So just look at this part. Look at this part first before moving forward, before getting too overwhelmed. All right. So someone starts pressing. Because whenever it's high, it's not being pressed, it stays here. If you press it, directly jumps out and do this and jumps into this while loop. Okay, someone just pressed. And when it enters that while loop, it's gonna run this one first, check the condition here first, if statement. So if the note index, which is the index the notes in the song, is not 0, it's gonna do this. But at the very beginning, the node index is 0. It is 0 at the very beginning. So it actually won't run the first one first. So it's an else case, actually. You know? And the counter TCNT3 is a counter register. As long as the counter and timer and counter 3 is enabled, that TCNT3, that register, the number there will keep counting. So if you register the counts at that moment to this variable, it logs the count at the moment to this variable. So the first time it enters the while loop, it doesn't satisfy this one, but satisfies the else case, will register the counts over there to this variable. And the next time it enters, the node index will be 1, so it satisfies this one, will comes into here, and looking at the counter, the counts in the counter register number 3 at that moment, right? And minus the previous one, which is the one being stored here, because that's the previous press. So you are getting a delta t in forms of counts. Does that make sense? The first time you register the count, right? And the second time it enters again, the TCNT3 will change because the time elapsed. And that one minus the previous price, you're getting the delta counts. And that delta counts is being stored in the price duration. Will get you that duration between the two price events. And then you immediately register the second price as a previous price. So the next time, the second price becomes the previous, and the third one becomes the current. And keep doing that. It's recorded, so you can always come back to the video and revisit, right? I have 3 minutes left. And then once all these were all the price events are done, right? Because the node index reaches a limit, the length of the copy song, it jumps out and will immediately check that if it's still being pressed down, because when you press it, it plays the note, right? So you want to hold it here whenever it's being pressed. You want to keep the play note to be true. I already told you the answer, right? So the first one is play note to be true, and the second one is just hold there whenever it's being held down. All right. If you release it, you don't play the note, because when you release it, it's quiet. You press it, it plays. You release it, it doesn't play the note. And then it's waiting for the second note. So you wait here, until someone presses it one more time. So that's another thing we cover today. Is just a while loop, right? Just hold there, waiting for the next press. So it should be while it's high, just holding there. And once all these are done, right? All the press events are done. You want to turn the play song, because you need to play either a success song or fail song. So you want to turn the timer 3 interrupt back on. It's just one liner. I already told you the answer pretty much. It just turn it back on. It's a timer 3 mask, and the TOIE bit should be toggled to be on, right? You can directly put that one liner over here. And if it's a success, okay, you give the song number to be the success song, and turn on the flag of the play song, play note. Basically just play song flag to be true, and then reset the index to be starting from 0, so you can start playing the first note in the success song. If it failed, then you play the fail song, right? And that's it. And then the next will be the ISRs. The ISR is the same as task 2.2. And I hope this will prepare you for the homework due on Sunday. Again, start working on it today if you haven't. Never wait until Saturday or Sunday. Okay, I won't be always available over the weekends. And I won't extend this for another time. It's going to be Sunday, okay? Firm, that line. All right? Please turn in these two in class, and that's it for today. So for Friday, I'm not having a lecture, so we'll meet over there, and you guys will directly work on this task. It will be a tutoring session for task 2.2 and 2.3. All right.
For the disabling or like not, do we use like the little like swoop or the exclamation point?
For which one?
Like, I don't know if I did it right. Like,
Oh, for the inverse?
Like that sort, yeah.
Inverse, I think is this.
Swoop.
Yeah,
Okay. And so it's the same one for the class or the fifth one, right? Because didn't we do the same thing?
Yeah.
So it's a swoop.
Mm-hmm.
Okay.